Lecture 7: Use-Centered Design Research, Observation and Task Analysis. The part is software design course mention a package approach to a requirement based on the book Contextual Design, Defining Customer-Centered System by Hughes, Bayer and Karen Holzbach in 1777. The book provides comparatively step-by-step guidance through a process with similar motivation to the described here, but does not emphasize theoretical concern or user study in a more academic HCI research context. This course gives more attention to individual research techniques that are often by within HCI and the social science context from which they are derived. A guest lecturer will be invited from the Cambridge Department of Social Psychology. Structure interview. Most software projects start with a series of the meeting in which the system requirements are established. The agenda of this meeting is often concerned with many other matters than the user interface. However, in effect, the people who will use the complete system might not even be present. The requirements are defined by representative, a system analyst for an internal project, or a market research for a product who may not have much experience of design for usability. For this reason, user interface designers often conduct studies especially to discover the requirement of the system user. One of the cheapest and most straightforward techniques is to conduct interview with the user. Interview must be careful planned to be effective. However, they are generally more or less structured, encompassing a select range of users. And taking care and encourage cooperation from users who may feel threatened or anxious. A structured interview is based around a set of questions that will be asked of every interview. Interview this need not necessarily be a long list, but they help to collect data into the common framework. And to ensure the important aspects of the system are not neglected, Chapter 13 of Price, Roger, and Sharp give far more detail about interview technique. Or observational studies. Observational studies are less instructive way of capturing data about user tasks and can also be more objective. They involve more intensive work. However, an observational study of tasks and take place in a fixed location can be conducted by making video recordings which are transcribed into a video protocol. This protocol can then be used for detailed analysis of the tasks, relative amount of time spent in the different subtasks, common transition between different subtasks, interruption of the task, and so on. Audio recording can be used for this purpose in certain domains, but these are less likely to be useful for task analysis than they are in thinking aloud studies. If a task ranges over a number of locations, the investigator has no choice but to follow the subject, taking notes or recording as best as possible. This is sufficiently difficult that ethnographic techniques are more likely than passive observation. An alternative is the use of diary studies, in which subjects take their own notes, but prompted to pay attention to specific time, event, or categories. Ethnography and field studies. Ethnography studies method recognize that the investigator will have to interact directly with the subject, but while taking sufficient care to gain reasonably complete and objective information. An ethnographic study will attempt to observe subject in the range of context over a substantial period of time and making full record using any possible mean, photography, video and sound recording as well as note taking about activity and the artifact that the subject interact with. Ethnography methods are becoming increasingly important in HCI to an extent the many technology companies will not employ an anthropologist as their first social science expert rather than a psychologist. In practice both set of skills are useful. Cognitive description of human performance, often called human factor by engineers, tend to be most valuable to detailed assessment and critique of the purpose design. Description of the mental model can be helpful in elaborating a design concept, but ethnographic observation can help to understand technology and product in completely new ways, perhaps leading to innovative new concepts. In this respect, ethnography can be considered as contribution to engineering requirement capture. In the traditional technique company, younger and trendy companies like the describe the whole process product concept identification, development, and refinement as user experience (UX) design. There are specialist books and conferences that report method and research from the artist's perspective. Example, EPIC, the ethnographic practice in industry conference, Dukes, designing the user experience, CIE, human factor in computing. HCI research tend to have skill in the this technique, but the product designer generally want a simple recipe that does not require them to spend a year or more doing fieldwork. Often the biggest problem they have how to gain a perspective of the what it is like to be a user, escaping the mindset of their own technical understanding and expectation of the product. A useful intermediate technique is to write fictionalist description of the kind of the person who will use the product to help the engineer understand what sort of person they are based on his or her personal experience. These are personal might be derived from ethnography fieldwork or from conventional market research data. They are particularly popular technique in Microsoft, where personal description include photograph, presumably of actor, fictional biographies, and description of why this person used computer. Product design then process on the basic that the designer tries to accommodate or ideally charm, assist, and delight this range of fictional people. Two Microsoft staff members, Pruitt and Gruden, have written a brief paper explaining the use of the technique. Chapter 12 of Priest, Roger, and Sharp give them far more detail about ethnography and observation technique. Prototyping. Prototyping is become increasingly important as the software design method, particularly addressing the problem of developing user interface within a strict waterfall development model. Companies that use waterfall model have placed increased emphasis on accurate portrayal of the user interface at the specification phase. After finding that the majority of specification change arise from the client not understanding the requirement for user functionality. In terms of mental model theory, this could be expected. Clients who have no imagine of the interface that they will operate are unlikely to have the useful mental model of system behavior. If the system can respond in the complex way, it is difficult to appreciate this from static figure and specification, so the specification phase of the project often use rapid prototyping tools and construct a functional user interface. This prototype can be demonstrated to client and used as the basic of discussion. If a spiral development model is adopted rather than a waterfall, and the prototype can be refined iteratively until the full system functionality is achieved. Incremental prototyping requires that the rapid prototyping tool also meet the engineering requirement of the final system. If such a tool is not available, an alternative is deep prototyping, in which one aspect of the system functionality is fully implemented before developing the rest of the interface. These common approaches to the prototyping are quite different to the prototyping technique that have been found to be successful in developing novel user interface. Many product designers believe that creativity in the product design process is directly related to the number of prototypes produced. HCI research similarly emphasizes technique for developing a large number of prototypes, exploring different possible solutions and evaluating the usability of alternatives. This is in contrast to incremental prototyping technique, which encourage cost saving by using the first solution regardless of the usability properties. Further discussion of the philosophy of prototyping in HCI can be found in Billy Buxton's popular book Sketching User Experience 2007. Investigation to multiple prototyping requires low-cost technique for producing prototypes. Rather than implementing realistic system functionality, this often as generic graphic design tool with some scripting function. Early HCI research often used Apple HyperCard, and more recent work used tools like Flash. Simulation of the user interface are often present a click-through prototype, a sequence of simulated screen typical load in the PowerPoint, where the demonstrate move the mouse pointer and the position on the screen and click there, pretending that the system is responding to the action. In fact, is always advanced to the next slide. The demonstrator has to remember where to click to make it appear realistic. An even more radical proposal is low fidelity prototyping, in which the prototype user interface is made using control from the glue and paper. During evaluation, the functionality can be implemented using the Wizard of Oz technique. A person simulates the machine by responding to user action with the display of the new paper screen. The objective of building multiple prototypes is to investigate design alternative through evaluation with the actual user. This might involve a simple discussion in the participatory design workshop, a more structured interview, or use of think aloud to study the mental model that the user developed when interpreting the prototype. Theories of computer and social actor. When we are designing computer systems that will be closely integrated into a social context, we need, we need to consider a number of important properties of social context as expressed in the field of computer support collaborative work CSCW. These are broadly derived from specialist perspective in social science known as ethnomethodology and conversation analysis. This approach was popularized by Lucy Suchman, an anthropologist at Xerox PARC, in her book Plan and Situate Action. This book not only set an agenda for understanding user interaction that was independent of cognitive psychology, but also offers strong critique and the article intelligent technique on which cognitive science was based. The theoretical concerns of the here approaches are broadly speaking as follows. One, the thing that people say relate to the current situation, indexicality, in natural human conversation is not usually possible to interpret an utterance without knowing the context in which it appears. Social situations are constructed from the word, but the same word can be used to make very different situations. Compare hard labor and to labor of love. Do most social actions are made in response to the other people around you and the thing they do. Cognigency. It's seldom practical to make a detailed plan in the advance and then carry out an exact sequence of the action without change. But the plan are necessary and useful, so plan must be flexible. Alternative, a plan might be orientation rather than a specification of what to do. Indeed, most plans are in fact of the latter kind. 3. In social situations, the things that people say and do are organized in a way that makes sense to other people. Accountability. If someone does something that does not make sense within this framework, this makes him appear irrational, disruptive, or mad, whether or not his actions seem logical in his own mind. If you want to understand why someone said or did something, it is the context they are in that gives their action a meaning. Their point, if you will. Abstract theories and explanation about social action are often too abstract to help explain the details of social action, and so may not help in design. Nevertheless, and perplexingly, abstract theories and often used by people themselves to help giving meaning and sense to what they do in any situation. All four of these aspects of human behavior are different to the behavior of computer system. The semantic of computer language determines that particular language elements should always have the same effect. They are not indexial. Computer plan can be derived exactly from the statement of requirement, but it's seldom possible for a computer to improvise. Other than replanning for the scratch, they are not contingent. Computers do not behave in the same way as the people. Participating in social situations with the result that they often do things that seem arbitrary rather than accountable contribution to a conversation. Finally, computer always act according to rules program constructed to following computation theories. The computer itself not uniquely adequate to explain its behavior. If we are designing a computer system that will be used within social situations, we need a set research method that can be provide a remedial perspective that make the computer slightly less incompetent as a social actor. We can do this by observing real social action in context ethnography, reading about what we see at the level that not only what happened but why things were done in a way recognizable to the participants themselves. Take description and making detailed analysis of recording in order to understand the partner and rules of the situation work analysis. Chapter 13 of the Carroll book by Graham Button gives a more detailed introduction to the ethnomethodological studies of work method for analysis qualitative data. Despite the name ethnomethodology, such means work over theoretical critique rather than a methodology for design. The word refers to the study of ethno-methods that is contingent and accountable partner of human interaction and has nothing to do with any technical concern. There are some rigorous approaches to analysis of video data oriented toward this concern and used by assessment and others at Xerox. However, this requires specialist training and are probably too time consuming for routine design work. In case where is it necessary to take an open-minded approach to a qualitative data such as interview transcript or think alert protocol. Many HCI research use a technique known as grounded theory, in which individual statements are coded in categories in response to the data itself, rather than framed by prior hypotheses or assumptions about how users ought to interaction. Chapter 7 of the Trains and Cookbook gives the good interaction grounded theory. Lecture 8 Usability Evaluation Method. Summative Evaluation Technique. Summative evaluation often performed under the umbrella of usability testing is carried out of the end of the project after the system has been built to assess whether it met its specification or whether a project was successful. This is in contrast a formative evaluation where the main objective to contribute to the design of the product by assessing specification to the prototype before the system has been built. Formative evaluation is often analytic. It's processed by reasoning about the design, while summative evaluation is often empirical. It's processed by making observation or measurement. The evaluation carried out in the most part two project in summative in nature. Summative evaluation is also used frequently in research situations where the performance of a new interaction technique is assessed to scientific publication. However, summative evaluation is not so popular in commercial setting as in academic setting. After a system has been built, the creator tend not to be interested in the future advice. Many small companies consider that releasing a product is so cheap. Large, more established companies spend more on summative evaluation of new product because of the danger to their reputation if they were released a product that was very much inferior. For this reason, companies like Microsoft carry out summative evaluation studies of the all product before they undergo even early beta market release. Usability problem can then be tracked and resolved in the same way as the other software defect, using the same process as for functional bug found during system testing. Control experiment. The most common empirical method used in HCI research derived from its origin in human factor and experimental physiology is the control experiment. An experiment is based on the number of observation measurements made while someone is using an experimental interface. A typical measurement might be how long to Fred take a finish task A, task E, or how many errors did make he. A wide range of the alternative measurements are possible, including heart rate or other exotic biological data. However, we most often assume, as in the discussion of KLM and GOMS, that it is a good thing if interface allow us to do something quickly. A single observation of the speed is not very interesting. However, if Fred did task again, he would take a different amount of time, and if someone else did it, it would take an even more different amount of time. We'll therefore collect set of measurement and compare average. The set might be multiple observations of one person performing a task over many trials of a range of people experimental participants performing the same task under control condition as with most human performance. The measured result will usually be found to be normal distribution. A typical HCI experiment involves one or more experimental treatments that modify the user interface. A very simple example might test the question, how long does Fred take to finish task A when using a good UI compared to the bad UI? The result will often be that the good UI is usually faster to use than the bad, but not in every trial. If we plot the measurement, we find two overlapping normal distribution, and we must therefore compare an effect treatment relative to the spread in the population distribution. We need to know whether the difference between the average is the result of ordinary random variation or the effect of the change we made to the user interface. This involves a statistical significant tests such as the test, t-test, and other similar tests answer the question, what is the probability that the observed difference in the mean could have occurred simply by random variation. The idea that the experimental difference might just have been a random variation is called a null hypothesis. And it is important to remember that it is always possibility in any experiment. We generally hope that the probability was very low, that the observed difference is because we designed is really good interface rather than luck. In HCI research, we usually insist that the probability of the result being due to random variation is less than 0.05 or 5%. Good quality research results are normally based on experiment with the significance value p rather than 0.01, which can be expressed as we reject the null hypothesis with 90% confidence. Variation in control experiment. Some computer scientists find it surprising that one can draw scientific conclusions from the measurements that are different every time we make them, and even offer the opinion that the basic of HCI in probability and statistics instead of mathematical proof is a fundamental flaw in HCI research. This rather fatalistic. Everyone knows that the people are different. If there were no way to measurement the value of the user interface for a wide range of different people, there will be no change or progress in the user interface development. It is important, however, that we are aware of the source of variation in the measurement. These include variation in the task participant, changing the weekday of the week and the time of day, the effect of the treatment, the user interface improvement that we made, individual difference between experiment subject, different stimuli for each task, distraction during the trials needing grouping thing, motivator of the subject, accidental hints or intervention by experimenter or other random factor. The statistical technique used the sophisticated experiment isolated this kind of the factor and try to account from them separately in order to gain good understanding of the effect of the experiment treatment. Fortunately, over a large number of trials, all of these factors tend to combine into pattern of random variation within the normal distribution as predicted by the central limit theorem. The central limit theorem and the total null hypothesis testing technique are beyond the scope of this course. A, a useful introductory text on the experiment design is Robson experiment design and static in physiology. A brief summary of the most important principle is given in section 14.4 in Priest, Roger, and Sharp. A more serious concern in the kind of research in the fidelity of result is the effect being measured really produce response of the treatment internal fidelity. Would the observed effect generalize of the situation beside the precise context of the experiment? What exactly was the mechanism by which the effect occurred? Is there some established HCI work or psychological theory that can explain it? Could it be replicated if you repeated the experiment with slight variation? Older user, for example, or different model of the computer. In order to avoid this potential criticism, HCI research often try to use experimental tasks and contexts that they have good external and environmental fidelity. They are as close as possible to the situation in which the interface will really be used. Chapter 6 of the Child and Cookbook give very useful advice and statistical argument. HCI, while up chapter 9 by Alan Dix has an excellent discussion on fidelity and theory. Taking a lot of studies, although not really experiments, they are often conducted without hypothesis and the data is qualitative rather than quantitative. Control study in HCI often uses the think a lot technique described in the earlier lecture to gain insight into the way the user have interpreted a prototype. When used as a rigorous scientific technique, a great deal of care is taken to ensure that the user vocalizes every thought they are aware of, and the recording is transcribed and analyzed in the detail of evidence of particular mental process. However, in a commercial context, the thing allow protocol can seem much more like real-time evaluation feedback, in which are simply asked to make many comments as possible on the user interface. This may not provide very much scientific insight, but at least it avoids the problem of the user of the spend and how using the new system, then say almost nothing in the way of feedback. Other empirical technique. Hypothesis testing is very useful technique for making quantifiable statements about improvement and in the user interface. It also hides a lot of useful information. However, experimental subjects usually have a lot of useful feedback about the interface that they are trying, but there is no easy way incorporate this into a statistical analysis. Instead, we use a range of other techniques to capture and aggregate interpretative report from the system user. Survey. Survey is include a range technique for collecting report data from population. The most familiar types of the survey are the public opinion polls and market research survey, but there are much greater range of the survey application. Surveys are usually composed of the combination of closed and open question. Closed question require yes or not answer or choice on the Likert scale. This is familiar 1 to 5 scale, asking respondents to rank the degree to which they agree with the statement. Closed questions are useful for statistical comparison of different groups and correspondents. In open question, the correspondent is asked to compose a free correspondence to question. A letter requires a methodical coding technique to structure and context of the response across the population and is particularly useful for discovering information that the investigator was not expecting. Questionnaires. Questionnaires are particular type of survey. Interview study of the sample population are also a form of survey. Questionnaires are generally used to gather response for the large sample and can be administered by email as well as on the paper. Discussion of the issue that can be encountered in questionnaire study in available online at http://kme open uk people paul summers 98 question point html. Chapter 7 of Fields Roger and Sharp give advice on data collection using questionnaires and interview. Field tests. Some very successful field tests. Some very successful software companies have carried out field testing of their product in addition to field studies at the specific pace. And well-documented example is the Follow Me Home program carried out by Intuitive. After the release of the Quicken product, company research select customer at random when they are buying a shrink-wrapped copy of the Quicken in the store. The research then went home with the customer in the order to observe them. They are read the manual, install the product, and they use it for their home financial management. Intuit directly attribute the impressed success of the product to this type of the exercise and to the observation studies the carry out during initial product planning, quicken survive and the assault from the Microsoft product price at the predatory $15 and Microsoft later made a bid of 1.5 billion to buy Intuited. Intuited continues to the thrive and the independent company and the all member of staff from director programmer and expected to spend at least 10% their time visiting customer to understand user need. After 14 of the pre-region Roger and Sharp discuss field studies. Bad evaluation technique. Some user interface developers use evaluation techniques that are practically useless. Unfortunately, this technique can even found in some published research in the computer science. This section includes as a warning to interpret such results with great care. Simple subjective reports seldom give useful information about the interface usability. When the users are shown the shiny new interface next to the tatty old one, they will often say that they like the new one better regardless of the usability. There are many circumstances in which a person's introspective feeling about their mental performance is not good predictor of the actual performance. So this type of report is unreliable as well as open to bias. Some research propose a usability hypothesis then does not test it all. It was proposed that more colors should be used in order to increase usability. This type of statement is speculation rather than science. Designing novel user interface without any kind of experimental testing is rather pointless. There, there is a great deal of variation between different people is their ability to use different interface. This may result from different mental models and different cognitive skill, different social context, and many other factors. Any conclusion drawn from an observation of only one person must therefore be very suspect. Unfortunately, many user interfaces are developed based on the observation of the single person. The programmer, the introspection of the user interface developer about his or her performance is seldom relevant to user. The word intuitive is often used in the discussion of user interface to summarize theories based on all the above, so should consider it a danger sign if they use to describe the effectiveness of the particular user interface design without any future specific detail of empirical evidence. Formative evaluation technique in the system testing as described in the part 1A software design development cost can be minimized by finding bugs as early as possible in the software development cycle. The same the same applies to usability bugs. It is far more useful to identify potential problems before the system is built than after it. Formative evaluation describes studies that are carried out as part of the design process. To the some extent, formative evaluation can be carried out simply by inviting a usability expert or representative user to review product plan and specification and offer their opinion. A more formalist approach to soliciting an user opinion is Platter design method, where representative users take part in design activity, perhaps structured in the way that means they do not have to learn too much the technical jargon, but can concentrate on the way they are likely to interact with the user interface. A more formalized approach to engage with a usability expert is via technique such as heuristic evaluation, where a panel of expert review proposed user interface on the screen at the time, assessing whether it meets some predefined set of the heuristic criteria for good usability. Formative evaluation using cognitive dimension of notation. There are also more theoretical motivated techniques for formative evaluation. The cognitive dimension of notation can be applied the checklist style. As we heuristic evaluation, however, is more useful to apply the dimension more broadly to consider both user need and potential general approaches to the design. At this level, all this consider evaluative in the sense and the designer are always having to evaluate which are the best option of the trade-off in the final product. Formative evaluation using cognitive walkthrough. The cognitive walkthrough method is a structured analysis approach the essential usability earlier in the project. The author Lewis and Poussin applied their own theory of the exploratory learning called CA+. Further details of the CA+ theory are not important. The CW method itself expresses quite clearly what are the consumption and the applicability of the theory. Behavior model. The model of user carry out tasks through exploratory learning involved for basic phase. And model describe how the notation user set accomplish with the system. A typical goal will be expressed in terms of the expected capability of the system, such as check spelling of this document. The model describes how the notation user search of the interface for currently available action. The availability of the action may be observable as the presence of the menu item of button of available command line input. The model describes how the notation user select the action that seem like to make progress toward the goal. The model describes how the notation user perform the select action and evaluate the system feedback and for evidence that progress is being made toward the current goal. Evaluation procedure. The evaluation procedure is based on the manual simulation of the national user interactively carrying out the stage of the behavior model. Not the users themselves are not involved. CW is the methodical approach to guessing the need of a real user but without the difficulty and expense of the required actual sample user for observation. The evaluation is conducted by interface designer and by group of peers. This group includes nominated scribe who will record the result of the evaluation and facilitator who is responsible for the smooth running and the evaluation process. The scribe and the facilitator are also active members of the evaluation group. The group of evaluators move through each the tasks considering the user interface at each step. At each step, they examine the interface and tell a story about why the notation user would choose that action. This story are evaluated according to an information processing model derived from the exploratory learned behavior model. One consider what the notation user current goal would be. Two, evaluate the accessibility of the correct control. 3. Evaluate the quality of the match between the control label and the goal. And 4. Evaluate the feedback that will be provided to the national user after the action. Section 50.3 of the Priest, Roger, and Sharp summary the cognitive walkthrough process. The ACM Conference of Human Factor in Computing System in 1995. Evaluation of Part 2 project. Known a substantial proportion of the mark for a Part 2 project are awarded for proper evaluation. In most projects, this tend to be summative. Formative evaluation work could be reported in the preparation or even implementation section of the dissertation. Non-HCI project. In all projects, whether or not they include a user interface component, empirical measures are considered to offer stronger evidence for the quality of your work and higher degree of scientific rigor. Empirical evaluation involves taking measurement, perhaps of compile time and network traffic estimate. Most empirical measurements are not exact, so it will be necessary to make a number of measurements and report the degree of variance as well as the mean. Empirical results are particularly convincing if they offer the comparison, the either comparing performance of your system to an existing one or comparing earlier and later version of your work. Where comparison is being made and there is some variance in measurement, it is necessary to give some statistical evidence to support them claim the observed difference was not the result of random variation. Project with the project with the user interface. All of above apply to a project that do not include user interface. If the project does include a user interface or is interactive system, then some kind of user study will be appropriate. It's not expected that user study at an undergrad level should be large or time consuming to the extent of the tools carried out in professional HCI research program. This is mean that number of participants is likely to be small, and there might be substantial variation between them. A statistical signification test of an experimental comparison for an undergraduate project addressing a problem of relative complexity is unlikely to reach the 95% significance level expect of professional research. You and your supervisor and director of studies should not be worried about this. Most undergraduate machine learning projects do not achieve 95% statistical accuracy either. And even undergrad compiler implementation seldom succeeds in 19 or out of 20 independent trials because most of them never compile 20 different programs. In case where it's not feasible to gather sufficient quantitative data for statistically significant comparison at the 95% level, it's perfectly appropriate to report at the mean of the two samples along with confidence interval. This can be expressed graphically as error bar. On the estimate mean, your main concern should to be estimate the effect size rather than to be concerned with variability in your sample. You want to know what impact does your system have on user performance. Evaluation of user interface need not to not be quantitative, of course. In case where speed and accuracy measurement are not meaningful ways to assess your project, any of the qualitative method described about could provide useful evaluation. Think along study, interview, questionnaire, and observational study, and or even file trials. Where there is a lot of variation between users, it can be good idea to interview them and ask why. Ethical issue with the human participant. There are a number of simple precautions that you should take when conducting research involving human participants. Fortunately, there is a very straightforward for routine technology evaluation study. Nevertheless, you should review the guidance provided for those in the Cambridge School of the Technology and Physical Science who are working with the human participant. Last resort evaluation. A last resort, for example, if your project is incomplete, you could carry out a formative evaluation and report this in evaluation section of your dissertation. Either cognitive walkthrough and cognitive dimension of notation could be used for this purpose. However, not the industry practice is for such evaluation to be carried out by independent evaluator, not by the same person who did the technical design. If you carry out a formative evaluation yourself, try hard to be honest and even hard on yourself. Otherwise, those results are likely to be obviously biased and subjective, and will not impress examiners. It was also remembering that choosing an analytic technique rather than empirical one. Example, not basing your conclusion and measurement or observation of the system in use, will always plant suspicion in the mind of the examiners that you have chosen to do this because the system does not work, meaning the proper summative evaluation was not an opinion.